We are in Geometry, Module 2, Lesson 1, Elaborate, on page 68. So how are translations along the vectors a, negative b, and negative a, b similar, and how are they different? So this kind of goes back to our previous video, and you can even kind of refer to the your churn to help you try to answer this question. Again, putting it in your own words are essential. I just kind of provide a concept that you want to make sure, as long as you have similar concept, then you're good to go on these written parts. Okay, so let's see. They move the points the same distance but in opposite directions. So it's basically moving it forwards and backwards or whatever, whatnot, but along the same initial vertex. Okay. So a translation along the vector -2, 7 maps point P to point Q. The coordinates of point Q are 4, -1. What are the coordinates of point P? Explain your reasoning. So point P, if it moves by -2 for my x and 7 on my y, I get to this point here. So the question is, what was the original point P? What were the original coordinates for P in order to have this movement and change happen to its coordinate point to get here? So take a moment, pause the video. And so hopefully this is your answer you got. And that's your reasoning. So if some quantity plus 7 landed you at -1, then basically you need a -7 from both sides to figure out where 8 was originally, or excuse me, y was originally, which was -8. And the same thing with your x. If some quantity -2 gave you 4, then you'd have to add 2 to both sides to figure out what your x was. Okay. A translation along the vector AB maps points in quadrant 1 to points in quadrant 3. What can you conclude about A, B, and justify your answers? So if you remember, your quadrants go counterclockwise, 1, 2, 3, 4. So basically it was saying, what would it take to go from positive x, positive y to negative x's and negative y's? What would it take to move a shape from quadrant 1 to quadrant 3? Take a moment, think it out, and put down a guess, and that's all right. What do you think? So let's check your answers. So both A and B are negative. So points in quadrants have a positive x and positive y. Points in quadrant 3 have a negative x and negative y. So that means the horizontal and vertical changes were both negative. It had to go backwards and down. So A is negative and B is negative. Okay. So essential question check-in. How does translating a figure using the formula definition of a translation compared to the previous method of translating a figure? So take a moment. And rather than sliding a figure left or right and then up and down to translate, you slide it parallel to a given vector, a distance equal to the length of the vector. So not just doing it randomly necessarily and point left to right. You're now taking the hypotenuse, basically it's what's happening, and sliding it along the vector straight line of that. All right.